So I just wanted to come talk a little bit about a class I taught in the spring of 2013. So first I'll give you a little info about the class. So it's a special topics course, so about every 3 or 4 years I get a special topics course, and the question is always, what do I teach? There's so many options, and I only get this every 3 or 4 years. And so my research area is in graph labeling, and it is something that is very accessible for all levels of undergraduates. And so I decided to teach a course on graph labeling. And so I had anywhere from sophomores to seniors, both majors and minors, register for the course because they could count it for either of those two options. I had about 7 students that ended up registering. We had too many electives in the spring. We recently kind of rearranged things, so our numbers were a little low, but 7 actually worked out great, so I was happy with that. And we met twice a week, 75 minutes each day. And I actually received an AIBL small grant, which was really helpful to sort of motivate getting this course ready over the winter break. I had a nice set of sort of beginning notes for the course before it got started, so that sort of helped the first few months just kind of getting everything put together. So the structure of the class that I made for this particular class, I broke the successful part of the course. So my plan, IBL course, so I created these course notes, and I was going to hand out these notes every day, and then students were going to go home and work them and come present them, right? It's going to be beautiful. It's like, it's going to be great. And then what really sort of ended up happening, especially near the end, was they would come to class with nothing because they were sort of getting into this sort of more difficult material. And so we sort of changed the structure a little bit, where Tuesdays we worked in class, sort of in groups. They got together, and they worked on the questions that they were supposed to be presenting that day, and we kind of had a chance to sort of talk about those in class in a larger group setting, which had its pluses and minuses. And then Thursday was really the day that stuff got put on the board. So it kind of changed a little bit in terms of how I sort of imagined it, but it seemed to work really well for these students and sort of what we had to do. And I didn't really have a content issue, right? So it slowed things down, but I was okay with that because we were just there to kind of do interesting mathematics. So it worked okay. So what the notes sort of look like, I began with sort of introductory graph theory material because these students, the only prerequisite I asked of them was to have some linear algebra background just for mathematical maturity. So they had all taken linear algebra but hadn't necessarily seen graph theory before. So that's kind of where we started. And sort of, Mr. Lucas was just talking about students are very visual. And most graph theory books, if you open up a random page, there's a graph on the page. But I actually have very few graphs in this entire set of course notes because I actually wanted them to read a definition and then draw a picture of that from the words as well. And the notes themselves have 3 sort of activities or types of things in them. There are activities, there are exercises, which I used to call problems, but I now have Southwestern now has a president who doesn't like the word problems. So exercises they are. And questions. So we have activities, exercises, and questions, and those are what the students sort of had as sort of options of different levels of things within the notes. So I wanted to kind of give examples of each of those things so you can kind of see, and we're actually going to go through and do some of those things today, so you have to do some work in here. You might need a pencil, piece of paper. So this first activity is what I would do. Actually, this is sort of my road show, and I actually usually carry this stuff with me, and this is what I do if I'm going to talk about mathematics to a large group of people. And in particular, it is the very first thing we did on the very first day of class because obviously the students didn't have the notes before they came to class. So I wanted them to see what class was going to be like, right, on a daily basis, to know that they were going to be doing something every day. And I would have done this here, but on my drive to the airport, I forgot the pieces that I needed, right? The pieces, my thing that I always carry with me, yarn and scissors. I always have this everywhere I go for this particular thing, but I forgot it. So then I went to CVS this morning and thought I could compile something, you know, like what that could be string and yarn, but the closest I got was like ribbon and some weird scissors, and I was like, no, I'm not doing that. So this is, we'll just kind of talk through this one. But what I did think about actually on the way here was actually change the wording of this slightly. Normally, I'm the one that's sort of leading it, right? And I'm like, oh, let's do this, and let's kind of go through this. But I actually changed the wording a little bit in the spirit of sort of the inquiry-based model, is actually just maybe give them the assignment and have them figure out how to do it instead of sort of me modeling it. So this might be now what I would do on a first day of a graph theory explanation. Is I would give the class some students, right, some yarn and some scissors, and I would tell them that I want to see a visual representation of who has had classes with whom, right, using only the yarn in their bodies, and I don't care how many times you've had classes with someone, right, I just want to know if I left the room and came back in 5 minutes, right, would I be able to figure out from what you're doing, standing, right, like who has had classes with whom, figure out a way to model that for me, right, so that I can visualize that. So I actually used the example of Facebook friends in class. That's what my original was in the notes, and it turned out that only one person was Facebook friends with one other person out of these 7 students at a school of only 1,400 students. So I had this terrible looking graph as my example of this is what we're going to use to define all of our terms. And so we had actually had a class discussion at that moment of what are some other things that we could have done here, right, that would make this a little bit better. And I've done different things, like if you know somebody in the room, right, if you know their last name, if you know their full name, if you know, have their telephone number in your phone. But apparently Facebook Friends does not work as well as you might think. I don't know what's happened with Facebook, but apparently it's not as cool as it used to be. So anyways, the classes thing seemed to work a little bit better. And again, these students were really good in this class about helping me edit these notes all semester long. If they didn't like something, they told me. So it was really good. So these things were a constant edit and process, which was really helpful. So once they complete this sort of graph, right, and they move around, they get to kind of know each other, they create this thing, and then we have a chance to put that picture onto the board, right? So figure out a way to take what you've done, right, in this situation and draw it onto the board. So again, it gets somebody to the board, right, which is again this thing that they're going to be doing all semester. And then from that, we can then start defining the terms that they're going to need. Right? Here's what a vertex is, here's what an edge is, here's what degree is, and start talking about what all those things are, which is what we really want them to know, what all the vertices and edges are. And they always have this reference point to come back to throughout the semester. So that was kind of day one, was really getting some of the terminology down and getting this cell, right, of what IBL is and how we're going to do this, and this is what class is going to be like. So that's kind of where the course activity started, and this is an activity that came a little bit later. So after we went through all the graph theory introduction, I wanted to kind of transition into graph labeling, and if you've ever done any kind of labeling, one of the big things we do is we take a class of graphs and we say, can we do this thing to this class? And you know, graph theorists happen to love creating crazy names for all kinds of different graphs, and so I have this encyclopedia of different things that are very common. If you're a graph theorist, right, you take some dots and some lines if you're not, and then draw a picture that looks like something. So there are wheels, which you can imagine are some right dots around a circle with some spokes going toward another dot in the center, right? That would be like a wheel. You add one edge coming out of that center with a vertex at the end that's now an umbrella. I don't know. So right, I show them 3 or 4 of these. And then I want them to create a class of graphs, right? So this is your first activity. You get to create a class of graphs today, whatever you want. So just think of something that can be an infinite family. So you could change something, right, the size of something in your graph so that you could explore this for more than just one picture that's maybe somewhat interesting, but maybe not. So your idea is to take some dots and lines and maybe draw some sort of shape that you think is interesting. And see what you can get, and imagine that you could add or subtract dots and make it maybe smaller or bigger so that you can create an infinite family. So I don't know if anybody wants to create something fun of any sort. Graph theorist or no, yes? If you're not a graph theorist, let me know, and I can come help you. You're not, you've got some, yeah, you're drawing some things, that looks great. You got dots and lines, you've got it. Okay, so draw some things. We'll share here in a minute, and I'll also kind of give you some examples of what the students did as well. So I'm getting lots of nice graphs out. I don't know if anyone is willing to share. Are you still working? Yeah, you can draw them. You can describe it as well. It depends. Maybe you're more verbal than visual. That's fine. Is anybody willing to share what theirs looks like? All right. Anybody have a microphone? No? Amanda, do you want to?
I'll share mine,
Okay,
and
share
then
yours,
I'll pass
Amanda.
the mic to anyone else
See if
who
you
wants
can
to.
describe it. I don't
know if you can see my picture. I have a little dot, like picture a connect the dots with a giraffe, and then you can extend the neck of the giraffe to have your infinite family.
So maybe a couple, if you're a graph theory terminology, a couple cycles connected, right, with a line, that longer neck with some little edges for legs, little things.
I had some fun making a face. So you can't, it's kind of hard to see, but basically I've got 2 cycles for eyes and just a little thing for a mouth and a couple of triangles for ears, and then the part that makes it infinite is how many strands of hair you put in.
So you can add. So anyway, this is it was a fun day, right? These are just 2 examples, but this is the kind of things the students did as well. And they loved this day. They were just You know, this is also, you know, Southwestern is a liberal arts institution. These kids love this kind of stuff. Like, this is why they're at Southwestern, I think. So these kids had created glasses and bicycles, and there were some flowers, and some of these are real things. I think flowers are a thing that people do stuff with, so, or this is now a stemmed flower. She had a stem on her flower, but. So this is kind of a fun activity, and I like these kinds of activities because the students really enjoyed it and were engaged in a sort of creative way that I think inspired them to continue, like open-ended, right? There's no wrong answer. They could put everything up on the board, and it was fun to look at everybody's examples. So I really am looking for other ideas of things like this, right? Some other activities that students could do, right, within the lecture notes. So I don't know if anyone has any other suggestions. But that is certainly something that I'm looking to add into these notes is more of these kinds of creative days. One that I had that I came up with yesterday, just kind of creating an example, was to actually, after we go through some labeling, is to create a definition for their own labeling as well, right? And get to name it, right? Because the names of these things is part of the fun. So if anyone else has any other exciting, fun, like little activity things that you can think about, I'm actually happy to talk a little bit about those. I'll let you think about that, and then maybe during the question time, if you have something, we can talk about those. So quickly, I kind of wanted to give you a sense of what we covered graph theory-wise, and this actually took a little over half of the semester, and so I would actually remove some of this stuff because it took so long to get into the labeling, which is what I really wanted to do. So I would actually take out a few of these concepts. But it was really good also because it got them to really get into the graph theory and know what a tree was and know how to solve some of these graph theory questions. So there was a long sequence of these questions. This was probably the first, I don't know, 80 or so questions in the notes, or questions of various levels, but this took up some time. So I just kind of wanted you to see the kinds of things that I thought were important that would lead into some of the stuff that we did with labelings. I might take out Hamiltonian paths. We actually didn't use that very much. And some of the walks and path stuff we didn't use as much within the labeling things. But the rest of these things are kind of important to what we do within labeling. So, and this was pretty easy to write. This is what I mainly focused on over the winter break, was trying to get this section done. And it was pretty easy because there are so many sources for this. So there are a lot of really great IBL course notes for graph theory, and I kind of just printed them all out, laid them on the table, and just sort of piecemealed stuff together that was important for what I needed for what my students were going to need as they started to do graph labeling. And I took some of my favorite texts as well and kind of took questions out of the question section and used those as just regular questions in the sequence of exercises. And so that was pretty easy. Like, this is good. I've got this. We're all good. I'm ready for the semester. It's great. And now it's time to do some graph labeling. And I chose these three labelings. I did graceful labelings because that's kind of where it started. That was the historical beginning. Harmonious, and it's also subtractive labeling, which I wanted. Harmonious actually uses modular arithmetic. So there's a little section in the course notes as well, introducing them to modular arithmetic in case they hadn't seen that before. And then the magic graphs, which is the stuff that I actually do in my research, so I kind of did a couple different types of that. And really this sequence of course notes just came from the research papers themselves. I found the original papers, the original articles that introduced these labelings, and those are great because they have all the introductory beginning sort of classes. So you could just kind of pick and choose from those and sort of make the course notes straight out of the research papers. And then Gallian survey, if you don't know anything about labeling, Joe Gallian has this amazing survey that's online, and you can pick and choose from that too, is to kind of find these papers and figure out what's been done. And then I also have a text that sort of follows the notes from the magic section, is very similar to what is now in the IBL course notes. So. And it turns out the graph labeling, a lot of the questions were too hard. So because some of these questions get really hard really fast, they're really easy to state. And so what I really wanted help on, or have us sort of think about, is how can we make the sequences of graph labeling problems a little bit easier, or have some more low-hanging fruit to where they don't get so frustrated so easily. Because that's what ended up happening, right? When that Tuesdays they wanted to work in class, and then Thursdays they would go finally present stuff because they had to have time to think about it a little bit more than just outside of class where they would get frustrated so easily. So I wanted to kind of put up this example, and it might be too small, I'm not sure, to read, but this kind of looks like the beginning of graceful labeling. So there's this paragraph of a definition, some history, and then the sort of basic questions that I'm talking about. These are just really clarifying, do you understand the definition? It's something we would talk about in class more than like actually an actual problem that someone needs to put on the board, or exercise. So just thinking about knowing the definition of graceful, what are the kinds of things you can get for the edge label? And when you're labeling the vertices, are you going to use everything, or are you just going to use some of those things? And just being aware of what the definition means. So do they understand that definition? And then from there, like, there would just be some graphs. I have 4 maybe basic examples, like a path and a cycle, some very basic things that they can try to do labelings on. I didn't put those pictures here because that would make this even smaller. But that's kind of where they start. And then the next page actually was also okay. This is kind of, now we're gonna start trying to prove all these things. We start with a path, which is just a straight line of dots and edges, dots and lines, right, vertices and edges. It's pretty great. They do that pretty well. The star is next, so it's just a center vertex with some lines going out. Also pretty great. Students did well with that. And then counting how many different ways we can do that, like how are they different. And that was all great. So all this was pretty good. The caterpillars is a little tricky, but someone actually figured that out without any sort of assistance, so things were going well. And then we got to something like this, where it just sort of starts to be this page of like, prove all these different classes, because that's kind of just what comes next. There are some other little things in here that I took out that went well. But this is the kind of stuff that gets hard, and the question is, how do you make this easier, right? I mean, I can look at the proofs in the research paper, but a lot of them are just people figuring it out, right? Like, oh, I figured out that it's this pattern of numbers. So the question is, how do we make those easier, and how do we add in the sequence, right, to make those questions a little bit easier? So that's kind of the thing I'm seeking, right, is to make some of the low-hanging fruit available, because this is where they would get stuck, because when this list started to appear, of prove this, prove that. And that's kind of some things that we can talk about maybe here in the next few minutes. Really quickly, I'll just make some comments about their project. They had to go to the survey, pick something, find some articles, give about a 20-minute presentation. It turned out that all of them did interactive. I didn't give them the guidance. I said, you can do whatever you want. You can give a lecture. They all did this sort of inquiry-based, activity-based lecture. And one of the students even wrote course notes for another labeling. So I just took those. I'm like, I'm going to port those right in. So he took, like, it has a whole sequence of questions and definitions, and it's great. So they bought into it, and they all did these presentations. All 7 of them had some sort of inquiry-based activity in the middle of their sort of presentation, which was great. The student comments, I'll throw these up really quickly. These are the things that were in the evals from this course, and they're very generally positive, and it's all the things that you hear about IBL, like these are exactly what people say, and they are exactly things the students wrote about the course. So it was really great in terms of their response. There were just a few sort of maybe, like, I wouldn't call them negative comments, but the things that they struggled with, right, in terms of IBL are the general things you also hear. So, you know, some of the definitions they didn't necessarily love. They were hard to work with. They needed more examples, right? And that's okay. I'm not giving them any more, but they wanted them. They wanted more applications, which is actually a very good comment, so we can certainly think about adding those in. And then, like they said, when the questions got hard, it was hard for them as a group, right, knowing their grading situation and presenting, of being able to present sort of that equal number across the course, because that was kind of the thing, was you're supposed to present about the same. So that's kind of an overview. We have a little bit of time if you want to give some recommendations or questions or suggestions.
Hi, my name's Jeff Pear. I'm from Middle Tennessee State University. My question is about one of your student comments, freedom to explore lack of grade pressure.
Yes.
Tell me about the grading system.
Yeah, so the grading system, the presentations were, each time they present on the board, they earned anywhere from a 0 to a 5. A 0 was pretty much if they just stood up there and sat back down, which never happened. They usually put something. And then if it was an easy question, and we kind of talked about what, you know, like some of the questions were easy, it was only up to maybe a 3. The 4s and 5s are reserved for days, right, when they did like a really excellent, like a harder question and presented it, and it was completely correct. And I just kind of said I wanted an equal presentation, like I wrote on the syllabus, right? Over the course of the semester, you should present about 1/7. There were 7 of them, right, of the questions in the class. And they all, and you know, each day I went around, I knew who had more questions than others, so the people that didn't, right, got the first pick of the day of whatever question they wanted to do, and they went up to the board and put whatever they wanted to up, and they earned some points. And so I think it was just like they knew, right, that they knew if they hadn't done enough that they needed to do more. And so it's toward the end of the semester, those students that hadn't done a lot really decided, I'm going to work, and I'm going to work really hard, and I'm going to put everything up. Okay. And so I think it was just the atmosphere. I don't know, this class, it worked really well. I've taught an IBL course class before where it didn't work that well, and it wasn't, right? They were frustrated that they didn't get enough opportunities to present, or they thought my grading got an A- and they should have received an A. Where did that minus come from? But these students were all really happy with their grades, and they all did well. They all received A's and B's. I mean, I had no reason to not give an A or B because they all were there every day presenting a fairly equal number.
Thank you.
Hi, Frank Sturm from Auburn University. I'm not a graph theorist, but I can understand just having a list of those exercises where you're just basically checking on specific cases. And just out of curiosity, what is the motivation for checking, whether or not these specific graphs have a graceful labeling or a specific type of labeling?
It's usually a starting point, or there's a certain class maybe that you're interested in, right? Complete graphs are very common, right? That might be a way to model something in the real world, right? Or there are certain classes that are sort of relevant to what people do. And so then they're asking that question for that class because that class might be something that's really important modeling-wise. It's also just a place that people start. So if they're trying to get a more general result, like about any graph that has this structure, will have, graceful labeling or won't, right? If they can find a class that doesn't. So a lot of these actually, I wrote up there, you can't actually do, and then that could leave people to a more general, like any graph that has this property, can't. So that's kind of what it is. It's also a way for people to just get started in the question is just pick a class and try.
And so I can understand the whole point, just start somewhere, but is it, so kind of what I'm asking is it really necessary to incorporate all those types of exercises?
Right.
Could the time be spent maybe
Exploring
something
something
else
else.
or developing maybe a motivation for just a smaller class?
Smaller class, right.
So, I don't know.
Good, thank you.
Thank you for coming, and thank you, Allison, for that lovely presentation.